Okay, so that's kind of getting a very deep understanding of this, and also connecting it to this idea of arithmetic differences, because there is some similarities there, and it's also connected to this idea of slope, but in a different way. Slope and differences are to do with subtraction. Geometric ratios are to do with division and powers. Okay, so let's try to apply some of these. What is it for the geometric sequence? Okay, what's the 12th term? Well, what are the two things we need to know? We need to know a starting point, and we also need to know how it grows, or our ratio. So we have our common ratio of times 2. So that's one thing I'm going to say. So I'm going to start listing out these things. So my A value, which is very important, I need some starting reference, and I need to know how it grows. R is times 2. And so if I want to write my general sequence, then it's going to be 4 times 2 n minus 1. And so if I want to find out my 12th term, I'm going to times by 2. There's 11 steps between the first term and the 12th term. And typing this in, this is a very big number. 4 times 2 to the power 11 is going to be 8192. Okay. So the next one here is, which term number is 512? So we don't know the n, but we do know the end amount, we do know the starting amount, and we do know how it grows. We just don't know the power here. How many times did we multiply by 2? Well, we can just count it really, but we could, since the variable's in the exponent, we know how to solve these. We use logs. So I'm going to start by dividing here, so I'm going to get rid of that 4, just use the log expression here. So 512 divided by 4 is going to be 128, if I'm not mistaken, equals 2n minus 1, and then I'm going to use log. That's going to be equal to n minus 1, and then solving that log, 2 to the power, I think that's 2 to the power, I should know my powers here, 2 to the power 7, I think it is, 2 to the power 7, so that's, this value is equal to 7. So n value, there are 7 steps, so n must have been 8. We ended up at n equals 8 to get to 512. So I can actually just list this out: 4, 8, 16, 32, 64, 128, 256, 512. Yeah, that's the one I'm looking for. 1, 2, 3, 4, 5, 6, 7. Yeah, that's the 8th term. Okay. So this is so we are basically dealing with a geometric growth, which is an exponential equation. So we have this formula to work with. Here there are times where I'm going to use logs, because there are times I'm going to need to solve for the exponent, which is the n value.